talk about property-based testing, and it will be an introduction to property-based testing. More advanced concept will be spoken by Tomasz later. So it happens a lot of times when I talk about property-based testing, and like I can talk about this is really yet another testing talk. We had a lot of talks about testing, how to do it, why we should do it, on which levels it should happen, how many of different tests we should have, and so on and so on. But this talk is different, I promise. So in what way? Because a lot of people already said a lot of things about testing. Namely, like the big names are like Uncle Bob, which you may know, especially you are. It's organized by Scala, so it's kind of connected to JVM, if I'm not mistaken. So you should know Uncle Bob, as he wrote a lot of his like tutorials in Java. There's also Sandy Metz and all a lot more different people. So given that, you should be able to answer the question, why do we test? Why even bother? Like, I'm a developer, I know my skills. If I write code, it will pass, right? So not really. We don't have this kind of confidence when we write our code. We want to have a proof that what we wrote is correct. We want to be confident while refactoring, for example, or modifying some behavior. And unit tests are great for that. And like higher level tests as well, but like unit tests are the base for our confidence. They're really quick to write. They're great for regression testing, or if you want to write, for example, an algorithm, it's quite nice. But they don't find corner cases. So let's talk about some property-based testing success stories, and we'll start with React. That's a simple key value storage that's distributed. It's written in Erlang, so functional word, and the property-based testing was used to find a few calls to produce errors. And I don't remember if they were only like only insert or something. It was really simple, really not complex domain. The next one is LevelDB. It's a bit more known, and here is like the more prominent corner case, because there were like 20 something calls to make some errors, and there were specific calls to make like specific pattern of calls to make this happen. And then after fixing that, there were found like 30 something calls in specific order. So imagine like having to dig through logs because something broke, and having a lot of additional information, trying to find exact 20 calls. And you may know Volvo, the car company. So not only property-based testing found like over 200 errors in production-ready code. They also found error in protocol. So there were like errors in how it should behave, like one not in the code itself even. So you may ask, how many tests are enough? How do we find all these strange cases? So, for example, if we take the LevelDB, let's assume there are only two functions we can use. And if we want to write a test for the 20 calls, like 20 code chain to find this one. To find the to cover all examples, we need 2 to 12 power. So that's a bit of tests to write. And let's imagine that now we have to write for 30 calls, and maybe we want to find to check if something will happen if we've got 50 calls or something. So like the answer is there will never be enough like those kind of tests. If we've got unit tests, for example, we'll never write tests to cover every single case. Because it's simply, even with really easy case like two calls to database, it quickly grows and gets out of hand. So let's go to the difference between unit testing, and by unit testing I mean also integration, system, end-to-end, and so on, all different kinds of testing. And the property-based testing. So all those kind of like unit integration and so on, they do have in common like one thing, because it's example-based testing. So we give what goes in, what happens, and what goes out. So it's like a table of inputs, action, and outputs. And all that those tests do is go through this table and check if for given input and action we get expected output. If yes, then the test pass. If no, then it fails. And property-based testing is quite different beast because it's not based on those examples. It's based on properties, which I'll explain right now. So let's say we want to write we wrote our own reverse function. This is really simple case, but I guess it shows all the things quite well. So the property is something that is held true for all valid inputs. And what does it mean? It means, for example, if we reverse list, we'll get this list that is the same length. Of course, that is not alone enough for reverse, because our reverse function could just return the list itself. So, for example, we could check if after reverse the k element is on the length minus k. So, like how reverse works basically. And what we could also check is if we reverse the list twice, we should get the same list. So what, for example, this shows is one kind of property that it's reversible, and we can use that to construct our tests. So why we bother with those properties? Because it's not everything, and it will make sense in a moment when I talk about generators. Because this is really simple function. It will generate list. It will generate it many times. First, it will start with really low entropy and will increase the entropy. So, for example, first list will be one element with just one small number. Then it will increase the elements, and maybe some negative numbers will come. Then the elements will get bigger as well. And it does it a lot of times with more and more, so to say, with wider and wider inputs. So if we say that our inputs, our valid inputs are a list of numbers, then we'll get more and more complex list of numbers. And let's now assume that our reverse function works just perfectly, but it will remove 42 when we get a list with 42 elements with it, we will remove that 42 and we'll just reverse everything else. And let's imagine we got really big list with 42 in it, and it will be really hard to find that it was because of 42. Because, so for example, let's say it has like 150 elements, and we have to dig through to find why it happens. This is where shrinking, the third part, comes in, and it will try to find minimal failing test case. In our situation, that will be a list with only 42, and it will present to us as minimal failing test case. So the process is we generate input for n number of times. We can specify this number, and if we find something that fails, it's usually be quite big. For example, for the level DB, it will be like hundreds of test calls, of database calls. It will reduce it until it's like still fails. For example, if we remove 42 and leave only empty list, like the reverse will work properly. So this is the change that introduced error. So let's take a look on sample test. It seems like a lot for just simple reverse list, but it's like a bit of easy to understand example. So we generate list, we generate a random element that we can make any restrictions on the inputs that we want. We can create complex data structures as well. And then we assert on those properties we found. And if any one of those properties will be violated, then we'll get an error, and we'll get information with the smallest failing example. And we'll do that for n number of times. This is in default around 1,000, I guess. But you can fine tune it. For example, if you want to have it on your dev environment lower, so it's faster, but on CI take longer, or some nightly build, you can easily fine tune it. And there is a question: why should I care? I've got a lot of tests. I don't have time to write tests. I don't have time to write 3 asserts for simple reverse. So I don't know about your background, but I'm OP developer in my day work. So while I'm interested in functional programming, I don't do it right now as my work. So maybe some of you have the same situation. Why should you care? So this is available also not only in, like, this was created as Haskell library. It has been ported to many different languages. And so that's the first, the first thing. It's not available in your language. It is probably, or you can just use some bindings. And it's really great for object-oriented programming as well. Everywhere where we have some kind of validations, especially when it's user input validation, it's a bit personal, but recently we had strange bug due to some strange user input, and we never thought about it. And this could save us some time. But yeah, you will never predict what users will input, and this tool will generate such crazy stuff, especially when it comes to strings in Unicode. And basically, you can easily test a lot of different stuff. I said unit test for algorithm, but there are some strange corner cases for algorithms as well. So maybe it's easier to provide an oracle that's different kind of property, so we know something works good and returns proper result. so we can assert that our implementation is correct with the so-called oracle. And like if you are a functional programmer, then of course this all still apply, but it's easier just to grab some existing lib, because it's like this thing is more popular in functional world, obviously, as it comes from academic functional programming. But like user validation, algorithms, and all stuff, this still applies here. So I told how it's all rainbows and kittens and unicorns. So is there any bad stuff? So it's time consuming in both, like there's learning curve to, it's hard to find good properties. In the beginning you'll sit down and think, I really don't know how to like try to test it. And the example with list, the last property was actually suggested by Tomek when we were reviewing this presentation. It was like, okay, but we need one more because it's not enough. So it's a skill, and it's a skill that takes time to attain. And it also, if you run your tests thousands of times, it will take way longer time than just simple unit tests that will do one thing and check. So be prepared to, if you go with this, be prepared that it can make your test suite take more time to run. That's why I mentioned fine-tunings on dev environment, maybe take less tries and more tries on some nightly build. So it's like unit tests are a bit of reverse. They are simple and quick to write, but they do not find a lot of things. This finds a lot of corner cases, but may take way more time to write and run. And yeah, I guess I rushed a bit for this, but it's like a just introduction, especially that Tomasz will take the topic after me. If you've got any questions, I'm happy to answer them. And if you want to like follow me everywhere, I'm basically Dread anywhere. So yeah. Any questions? Tak, trochę.
No questions? So you were playing with this property-based testing in Elixir?
That's a bit, but as Elixir is not my day job, it was just playing around. Yeah. It works really well, especially with the new additions to Elixir with generators that are built in with 1.6 or 1.8. I don't remember. It was on last year's conference.
So they decided not to make it part of language in the end.
Oh, in the end, okay.
So,
okay. I'm a bit out of date on that. So, but yeah, it works quite well. And yeah, if I were writing Elixir code, production ready Elixir code, I would definitely use that. Especially like the user input is a low-hanging fruit, so it's easy to it's relatively easy to write than some other more deep stuff. I mean, deep in your domain, for example, or your logic.
And your day job, what language?
I'm a C# developer on my day job.
Do you have the library?
There is library in F# for sure. But yeah, like I would really like to do it but right now we don't have time to to do it. But yeah, in my previous job I tried some dummy tests with that, and they found some funny stuff. So yeah, also in C#. But
so there is some support for this in C#.
Yeah, there is a F# quick check, and you can use easily F# with C#. So by proxy, I'm not. As I found the F# one, I didn't look for C#. Maybe there has been some port, but I'm not sure.
Okay, thanks.
Yeah.
Well, in all of my honesty, I think that implementing the quick check style or property-based testing framework in any language that properly supports generating anything is fairly simple. If you take a look at I think it's even in Runar Bjarnsson's book, Functional Programming in Scala. But they implement quick check from scratch, and it's like several hundreds of lines, not much. So it's a fairly simple concept on the theoretical part, but on the implementation part, when you work with it, it tends to grow both on you and on your code base. Well, I think I'm not a proponent of unit testing at all. On the contrary, actually, but if you, a common case after, we know the idea, and common problem when a person joins a team, for instance my team, and we do have lots of quick check testing, and then the first thing they stumble upon is they want to implement a property test for a given property, and it looks exactly the same as the actual implementation. And I think this is like the most problematic thing in the very beginning, the first hurdle people face, and it's even harder than to swallow than the processing time and the conceptual level. The biggest problem people have is that they implement the same thing in tests that they implement in actual production code. And you hopefully mentioned the Oracle generators. So the Hilo Weil, I think that's the name of the guy who figured the idea. That's a really interesting concept that solves lots of those issues. So it's good that you pointed people to that.
Yeah, but Oracle, it's like good idea, but it's not always the perfect case. Like one of the great examples of Oracle is if you want to rewrite something, for example, for speed or whatever reasons, and you know that something that you are rewriting works, like produces proper output, but is problematic for different reasons. But yeah, it's like as I said, it is a skill that it has a steep learning curve. It's not really easy just to jump in and start writing property-based tests. So it's way easier, like just to write unit tests, right? Like the simples is just act and assert, and that's it, and you're fine, yeah. And it's really easy to just write a lot of them.
Yeah. On the other hand, with property-based testing, what you get is that when the property-based tests are implemented right, then they are not tightly coupled to your implementation.
Yeah.
And this is like, if you want to change a lot in your implementation, when you have only unit tests, you can actually throw them away. Because they probably are so tightly coupled to your implementation that you can't really benefit much from them. If you do, huge refactor.
Yeah. And we were talking the other day with Tomasz about what property-based testing, what the property-based testing is not good for, and we thought we got some examples, but then it got like, no, but you can do it actually. So I guess you can save yourself a lot of typing when it comes to tests when you are proficient in property-based testing and you use them, maybe even each set. So you had a question as well.
Yeah, I understand that it's quite hard to find properties to test initially, but do you have any experience using the opposite of property-based testing? I know that there are some libraries that, given some production code, it will discern properties about your code, and then you sort of go through the properties and think, oh, well, that makes sense, this doesn't make sense, and you can find corner cases that way.
I haven't heard about that. I know that company behind Quick Check has like the consultancy, so they will come and find the properties for you and will help with your code, but I haven't heard the concept of finding properties. And like using the Quivik, the company behind QuickCheck, found those errors in protocol using like they implemented the properties from protocol, and for valid inputs they were always false. So that's how they found them. Yeah, but that's interesting concept, but I don't know how theoretically it stands.
Well, I can share some links with you maybe.
Yeah, sure. This is really interesting. Someone else? Or?
Okay. Thank you again.
Thank you.